Hello everyone, I am Dr. Rajesh working as assistant professor in GMN College Ambala Kent. I am with you with a new video lecture, and in this video lecture we will be studying this particular problem. This problem is requested by one of my student, so I am taking this problem and now preparing the video lecture. Now firstly we shall read the statement and understand the statement of the problem. If a particle is projected from an apse at a distance a with velocity from infinity, means the particle's velocity at apse is the velocity which it has achieved when it has come from infinity, under the action of central force which is given by, so action of central force which is given by m r raised to the power minus 7 is equal to m r raised to the power 7. Then prove that the orbit is the equation of the central orbit is this much. Now if we draw uh, the diagram, something like it will be like this. Say this is apse, this is apse, and this distance is a, and the velocity at this particular point, say it is coming from infinity to this point, so velocity, this is infinite distance, and this says point P, that is apse, okay, and this is at a distance a, and this when it comes from here, this has acquired velocity v, say it has acquired velocity v, and v is the velocity at apse p when it comes from infinity. So this is velocity at p from infinity, and we know that the formula for velocity from infinity is given by v square is equal to minus 2 infinity to point a f d r, that we have derived in the next video lecture. So I am going to put the value of f from equation 1, m by r raised to the power 7 dr, which is further equal to, m is a constant quantity, so this will be independent of integration, and r raised to the power minus 7 integration will be minus 7 plus 1. So this will be minus 2m r raised to the power minus 6 divided by minus 6, minus 2 minus, and it is 3, m by 3 r 6, and limits are from infinity to a, from infinity to a, this also from infinity to a, infinity to a. M by 3 is constant quantity. Now put a6 minus infinity is equal to m by 3 a6 minus 0 is equal to m 3 a6. This implies that velocity at apse, which is velocity from infinity, is equal to m by 3 a6, and you are going to name this equation as equation number 2. Now this velocity is the velocity at apse, and this could also be the velocity of projection. If something is starting from apse, then that could be the velocity of projection at an apse. This is m by 3 a6 square root, okay. Also this is velocity particularly at apse, this is not a general velocity, this is particularly at apse, this is the velocity. And in case of general velocity, we know that pv is equal to h, where h is a constant quantity, h is a constant quantity. So this is the formula for general velocity. Okay, and we know that at apse p is equal to a and v is equal to v. So you see, again see the figure, this one here, you see this is the tangent. Okay, and this is the perpendicular upon the tangent, angle is 90 degree. So the length of the perpendicular will be a, this radius vector will be the length of the perpendicular, so p is a at apse, p is equal to a, and velocity is capital V, velocity from infinity. So I am going to use this in this particular equation, and you may name it as 3. Using these, in 3 we get a v is equal to h. This implies that, because we are interested, by using this condition we are interested in finding the value of h, where h is a constant quantity. So this value could be found by the by using the some condition, and this condition is the at apse. So scaling both sides, we get a square v square is equal to h square. This implies that h square is equal to a square, and v square from equation number 2 is m by 3 a6. This implies that h square is equal to mu 3 a4, and you are going to name this as equation number 4, Now see, from equation number 3 we can also write that from 3 we can write that v is equal to h by p. This implies that v square is equal to h square by p square, where v is the general velocity, this v is the general velocity, and h square 1 by p square we again know that is equal to 1 by r square plus r4 dr d theta whole square. We also know that r is equal to 1 by u. This implies that dr d theta is equal to minus 1 by u square du d theta. This implies that v square h square u square plus u4 minus 1 by u square du d theta whole square, which is further equal to h square u square plus u4 du d theta square. This will cancel out. This is equal to h square u square plus du d theta whole square v square. Okay, and you will name this, and h square is from we have determined h square from equation number 4, mu by 3 a4 u square plus du d theta whole square by using 4. So I am going to name this equation as equation number 5. Again rewriting the 5, I could also write v square is equal to mu, just for the sake of clarity I have written it again. This I have named it as equation number 5. Okay, also we know that if force is known, because here the central force is known, again the expression for velocity is v square minus 2 f dr plus c, where c is arbitrary constant. So this will be v square minus 2, it will be mu r raised to the power minus 7, because central force is given here. So that is why we have used this particular formula also. Central force is r raised to the power minus 7. we have already discussed these two formulae for the velocity, and I am using mu is a constant quantity minus 6 plus 1 integration minus 7 plus 1 c minus 2 mu r minus 6 plus c mu r6 3 plus c. This is v square, implies v square is equal to mu 3 r6 plus c, where c is arbitrary constant and whose value is to be determined. At apse we know that at apse we know velocity is equal to v, and this is further equal to mu by 3 a6 square root. This is by equation number 2. This is by 2. Okay, and at apse r is equal to a. So using these in this particular equation number 6, we get, using in 6 we get v square will be mu 3 a6 is equal to mu 3 r is a6 plus c. This will cancel out. This implies that c is equal to 0. So now using this c is equal to 0 in equation number 6, we get v square is equal to mu 3 r6, and this is named as equation number 7. Using 7 and 5, using, and this is equation number 5, using 7 in 5, we get v square is given by 7. This is mu 3 r6 is equal to mu 3 a4 u square plus du d theta whole square. Okay, now cancel out, 3 to 3 cancel, mu cancel, and 1 by r is u. This implies that u6 is equal to 1 by a4 u square plus du d theta whole square, because u is equal to 1 by r. Now this implies that u6 a4 is equal to u square plus du d theta whole square. This implies that u6 a4 minus u square is equal to du d theta whole square. This implies that u square u4 a4 minus 1 du d theta whole square. This implies that du d theta is equal to plus minus u4 a4 minus 1. Now here both sign plus and minus. We will see that which sign to retain and which not to. Again I am revoking the figure. In this figure, this is also apse, and either apse can be taken. As this r is here maximum, so in this problem maximum is taken, and it is coming from infinity. Okay, here r is maximum. From there on, and this angle can be taken as theta is equal to 0. From there on, if we have to take the positive sign, we have to take this as apse. If we have to take the negative sign, we have to take this as apse. So I am here going to take the positive sign, so this has to be taken as apse. So this r is maximum, so further on there on r will decrease, and as r will decrease, this implies that u is equal to 1 by r will increase as theta will increase. Therefore u is increasing as theta is increasing for that particular apse. If we are interested in positive sign. So here I am taking the positive sign. This implies that if u is increasing, as theta is increasing, du d theta is positive. So taking the positive sign there, du d theta is equal to u square u4 a4 minus 1, and we know that u is equal to 1 by r. This implies that du d theta is equal to minus 1 by r square dr d theta. Okay, fine. Now changing these here, minus 1 by r square dr d theta, u is 1 by r, a4 r4 minus 1. This implies that minus 1 by r square dr d theta is equal to 1 by r, a4 minus r4. This is r square. This will cancel out. This implies you see, again we write that minus dr by d theta is equal to 1 by r, a4 minus r4. Now separating the variables, we get minus r dr a4 minus r4 square root is equal to d theta. Integrating both sides, we get r dr a4 minus r4 square root, this integration d theta integration plus arbitrary constant c1, because c is already used. This implies that in this integration put r square is equal to t. This implies that 2r dr is equal to dt, implies r dr is equal to dt by 2. So this implies that minus dt by 2 a4 minus t square square root, this integration theta plus c1. This is implies minus 1 by 2 dt. This can be written as a square square minus t square is equal to theta plus c1. This further implies that 1 by 2, and this will be cos inverse t by a square is equal to theta plus c1, because 1 by a square minus x square dx integration, and here is minus sign, is equal to cos inverse x by a. So this will be the integration where c1 is arbitrary constant and whose value is to be determined. This equation can further be written as multiplying both sides by 2, and t was equal to r square 2 theta to c1. This implies that cos inverse r square by a square is equal to 2 theta plus c2, where 2c1 is equal to c2 is new arbitrary constant, and value of c2 is now required to be determined. At apse, again using the condition at apse, r is equal to a and theta is assumed to be 0 at apse. We assume that the initial initial line is along that particular line joining the center of the force and the apse. So theta is 0 at that particular point. Using this over there, cos inverse a square by a square 2.0 plus c2. This implies that cos inverse 1 is equal to c2, implies c2 is equal to 0, because cos inverse 1 is 0. Using in the above equation a, we get implies cos inverse r square by a square is equal to 2 theta. This implies that r square by a square is equal to cos 2 theta. This implies that r square is equal to a square cos 2 theta, which is the required equation of the central orbit. So in this every condition we have used at the apse. Velocity at apse we have used capital V given by the equation 2. P is equal to A at apse is used. Theta is equal to 0 at apse is used. So every condition at apse is used, and we have used the two different formulae for the velocity and general formula for the velocity, and any constant involved is evaluated with the help of the condition at apse. So this is the required equation of the center orbit. So this is all I have from this lecture, and if you have liked the video, please like, subscribe, share and comment. This is Dr. Rajesh saying you goodbye. Thank you very much. Thank you for watching. Thanks.